Dear viewers, we know that global aviation landscape is undergoing a significant transformation, with the rapid proliferation of unmanned aerial vehicles across both civilian and commercial sectors. However, their increasing integration into national airspace systems introduces a new dimension of safety risks that demand proactive management by aviation professionals. To start with, we know that operational landscape of UAVs is very different than conventional aviation platforms. Unlike manned aircraft, UAVs operate with varied levels of autonomy. These are piloted remotely, often by operators with minimal aviation background, and may lack standardized detect and avoid capabilities. This divergence from traditional aviation frameworks creates unique safety challenges, particularly in shared airspace. Let's explore the primary safety risks associated with UAV operations. First one is airspace incursions and mid-air collision risk. UAVs are frequently spotted in the proximity to airports and flight paths, raising serious concerns of potential mid-air collisions. Mostly without effective traffic collision avoidance systems and relying on GPS navigation and line-of-sight operation. Incursions into controlled airspace are often the result of operator error, ignorance of airspace classifications, or GPS signal failure. Second risk is technical and mechanical failures. UAVs are susceptible to communication loss, software malfunctions, and battery failures, any of which can result in uncontrolled descent or flyaway incidents. Smaller drones are particularly vulnerable to environmental factors such as wind gusts or electromagnetic interference. Next risk is operator human factors and inadequate training. Very often UAV operators are hobbyists or technicians without formal aviation training. As a result, human error, ranging from poor flight planning to incorrect equipment setup, remains a dominant factor in UAV incidents. Additionally, fatigue, complacency, and over-reliance on automation further elevate operational risk. In the fourth place is the cybersecurity and system integrity threats. As UAVs rely heavily on digital communication and software, they present cyber vulnerabilities. Unauthorized access to flight controls or payload systems can lead to data breaches, hijacking, or intentional misuse, particularly in high-risk environments, such as critical infrastructure zones or conflict areas. Last but not the least, is the ground and infrastructure hazards. UAVs operating in dense urban settings pose significant risk to people, property, and infrastructure. Crashes caused by mechanical failure or loss of control may result in injuries, fires, or transportation disruptions. Additionally, sensitive areas like power plants and airports face increased threat from UAV interference. Dear viewers, having discussed the risks associated with UAV operations, now let's look at the strategies for risk mitigation. Main focus of these strategies is that UAVs are safely integrated into the broader airspace ecosystem, which essentially require a multi-tiered approach. First one is regulatory enforcement and airspace management. Civil aviation authorities must maintain up-to-date regulations that reflect evolving UAV capabilities and operations. This includes mandatory UAV registration for traceability, remote ID systems for real-time tracking, defined flight zones and geofencing to prevent access to sensitive areas, integration into unmanned traffic management frameworks for traffic deconfliction. Second is technical enhancements and redundancy, which requires that UAVs should be equipped with fail-safe systems, such as return to home and loss link protocols. Obstacle detection and avoidance technologies, using radar or optical sensors. Secure communication links and encrypted control channels to guard against interference and hijacking. Next is operator training and certification standards, which implies that standardizing training requirements must ensure consistency in operator competence. Therefore, aviation authorities and manufacturers must collaborate to offer tiered certification based on UAV weight, usage, and complexity. Promote the use of flight simulation tools for risk-free skills development. Mandate recurrent training and assessments for professional operators. Fourth is safety culture and incident reporting, which warrants that a proactive safety culture, similar to manned aviation, must be extended to UAV operations. It must include voluntary and mandatory incident reporting systems for events related to UAVs. Data sharing between regulators, manufacturers, and operators to analyze trends and improve safety protocols. Public education campaigns to increase awareness of UAV operating rules and responsibilities. Lastly, integration with manned aviation systems, emphasizing that ultimately, UAVs must coexist with manned aircraft in increasingly congested skies. This requires standardized communication protocols for beyond visual line of sight operations. Interoperable surveillance systems, like ADS-B or FLARM, to support situational awareness. Collaborative trials and joint airspace exercises involving UAVs and manned aircraft. We can conclude that rapid expansion of UAV applications in civil and commercial aviation is both a technological triumph and a regulatory challenge. Aviation professionals must ensure safe integration of UAVs into national and international airspace, with a key focus on vigilance, adaptability, and cross-sector collaboration. By addressing emerging risks with well-defined mitigation strategies, the aviation community can embrace the full potential of UAVs, while preserving the integrity and safety of the skies. Thanks for watching.